Fine.
Hi, welcome to the mathcenter.com. In this video, we are going to look at a proof for a very common formula that we use when we deal with problems involving arithmetic progressions, that is the sum to n terms. Again, we are looking at arithmetic progressions, AP, and we're looking at the sum to n terms, and we have a very famous formula. We have a very famous formula, Sn equals to n over 2, in brackets we have 2a plus n minus 1d. So this is the formula that we are going to prove. So let's start by maybe just talking about the nth term first. Okay, so when you deal with an arithmetic progression, we will start with a, then we'll go to a plus d, a plus 2d, and all the way, okay, and all the way up to a plus n minus 1d again. Okay, so the first term, let's write it down. This is t1, which is a, the first term, and then we have t2, the second term, in the AP, a plus d. What's d? D is called the common difference. Okay, okay, and then we have t3, and then t4, and so on. I have written the nth term, t sub n. The nth term will be a plus n minus 1d. Okay, so this is to get us going, the definition of what an arithmetic progression is. Now, where are we heading? We want to find the sum to n terms. Okay, the sum to n terms is given by t1 plus t2 plus t3 right up to tn. Okay, that's what we mean by the sum to n terms. Okay, so we like to call this S sub n. So I'm just going to call this Sn, okay, for simplicity. So Sn will be t1 plus t2 plus t3 right up to tn. Good. So some preliminaries first. Okay, so remember, t1 is a. Okay, catch the idea. Tn is a plus n minus 1 d. So what happens if you take t1 plus tn? Again, I'm giving you an idea, or rather I'm giving you the main idea involved in getting to the proof. So t1 is a, tn is a plus n minus 1d. If I take t1 plus tn, what do I get? 2a plus, okay, add this to this, you'll get 2a plus n minus 1d. One more, okay? So take note of this, yeah? Maybe I can write it somewhere. Never mind, I'll just leave it here. Let's write t2. Okay? t2 will be a plus d. Okay, so let me write it properly. Is a plus b. That's the second term. What is the n minus first term? So tn minus 1. Okay, so this is the term before the nth term. Again, what is t sub n minus 1? This is the term before the nth term. So that will be equals to a plus n minus 1. So this one here is now n minus 1 minus 1. So let's write it down. And you'll get a plus n minus 2d. Again, okay? t2 is easy. The second term is just a plus d. tn minus 1, this one here is the term just before the nth term. So you can plug in n minus 1 where you see n. So you get a plus n minus 2d. Okay? So now let's go ahead and take t2 plus tn minus 1. So take this plus this, okay? So this one here plus this one here, what do you notice? Okay, let me write it down for you. Okay, we have A plus D, that's T2, plus A plus n minus 2D. Okay, so T2 plus Tn minus 1. So I'm writing this down for you so you can see it clearly. Let's open this up. I have A plus D plus A plus ND minus 2D. Okay, we open this up. Let's collect our terms. I have A plus A is 2A, that's good. Then I have D plus ND minus 2D, so I'll have plus ND minus D. Okay, D minus 2D is minus D. So now let's write it in a simpler form. You will have, okay, so take note of this. Okay, so T2 plus Tn minus 1, what are we getting? We're getting 2A plus n minus 1D. So you notice something here is the same. So T1 plus Tn is this. T2 plus Tn minus 1 is also this. Now there's a reason for this. So I'm going to write it down here and keep it. Okay, so that I can erase the board here. So take note, T1 plus Tn will be equals to 2A plus n minus 1D, and T2 plus is also 2A plus n minus 1D. Okay? Okay, good. So now let's erase all these things and we can write down our proof quite easily. Okay? Okay, good. Let me just erase this. Okay. So let's write Sn again. Just for completeness, Sn will be T1 plus T2 plus T3. I think that should be enough. Okay, go on right up to Tn. Remember, Sn is the sum to n terms. So that's why you see T1 plus T2 plus T3 plus T4 right up to Tn. So I'm going to call this equation 1. And I'm going to rewrite this equation. Okay? I'm just going to reorder this equation. I'm going to write the last term here in front. So it will be Tn plus Tn minus 1 plus Tn minus 2. Okay? Plus all the way right up to T1. Okay? We'll call this equation 2. Again, I've not done anything. I've written Sn by definition is the sum of the first n terms. And this one I've just rearranged it, reordered it, which is more accurate, by writing Tn in front. So here it would have been Tn minus 1, that's what you see here. Before that would have been T sub n minus 2. And then you go all the way back, you'll reach T1. Okay? Great. So now I've labeled this equation 1 and 2. We can add it up. Okay? So if you write 1 plus 2, what will you get? You'll get Sn plus Sn, which will be 2Sn. And that will be equals to T1 plus Tn plus T2 plus Tn minus 1 all the way right up to T1 plus Tn. Okay? Adding these terms up. Okay? Adding these terms up. So this will be the last one. T1 plus Tn. Okay? So remember what is T1 plus Tn? 2A plus n minus 1d. What is T2 plus Tn minus 1? 2A plus n minus 1d. They're all the same. Okay, again, T1 plus Tn is 2A plus n minus 1d. T2 plus Tn minus 1 is also the same thing. So we are having 2A plus n minus 1d, okay, plus 2A plus n minus 1d, all the way up to the last one, which will be 2A plus n minus 1d. So how many of these do we have? N of those. So I can write, okay, n 2A plus n minus 1d. Okay, 1, 2, 3, 4, there are n of these. So we can write n times 2a plus n minus 1d. There's a 2 here. Let's bring it down. So I have Sn equals to n over 2, 2a plus n minus 1d. Okay, that's how we prove this formula. That's what we have here. Sum to n terms, n over 2, 2a plus n minus 1d, and we are done.